For this particular lesson, you are going to need your calculator and you will need your book. So I would pause it right now and go get those two things. Okay, we're going to look at e to the 2x equals x plus 2. You could solve this taking the natural log of both sides. Natural log because the base is e. If the base was 2 or 4 or 3 or 1.6 or pi, I would use logs. And I'm going to plug this into my calculator. So go ahead and pause while you plug that in. I have a bunch of other things in my calculator, so hopefully you remember how to turn equations on and off. So if you want to turn an equation on or off, highlight the equal sign. You push enter, it switches from being darkened to not being darkened, bold I should say. Okay, so I have these two equations turned on, e to the 2x, x plus 2. And when all else fails, I'm going to do a zoom 6. And there's my e to the 2x. And x plus 2 is a line. So we have our x plus 2. So this should be review, I hope. I want to find out where they intersect. Second, trace. 5 for intersect. I'm going to find the point on the left. First curve, somewhere along the curve, that graph that I want to look at, enter. Then it says second curve, enter. And then it says guess. So for guess, you want to put your cursor as close to that intersection point as you possibly can. And I got an answer of, it's hard to see on the screen, negative 1.98, comma, 0.02. It's hard to read on the screen on the video, but I got an intersection point of x is negative 1.98 and y is 0.02. Generally, you should round to the nearest hundredth. Move this over here. There we go. Generally, you should round to the nearest hundredth. Okay. And then let's find out where the other intersection point is. So second trace, 5 for intersect, arrow over, first curve, second curve, get as close to that point as you can for the guess. I recognize that the intersection, like down here, this line is blurry on the screen, but if I try to focus it, then the glare is going to be pretty bad. So I'm pleased that I finally have a view where the glare isn't horrible. All right, so nearest hundredth, I would say that x is 0.45. And y is 2.45. So this problem is 100% just on the calculator. All right, let's do another one. Let's do e to the x minus the natural log of x is equal to 4. I'm not going to lie, solving that up, would we take the natural log of both sides? This would be a tough one. Thank goodness we have the calculator. So go ahead and pause the video and plug it in. I already have it plugged in when you come back. So I'm going to turn off the previous two equations. You've got all kinds of equations. I mean, I think you have, how many options do you have here? You have 10 options. No one says you always have to use y1 and y2. So I have mine, happen to have mine in y3 and y4. All right, I tried to focus it a little as if you couldn't tell. So again, I'm going to do a zoom 6. So that first curve is e to the x minus the natural log of x. Y equals 4 is obviously a horizontal line. All right, let's see where the intersection is. So second trace for the intersection. First curve. So right now, my cursor isn't even on the graph. So I'm just using my right arrow key to kind of get my, there it is. There it is. I had to hold the right arrow key down to get it to show up. Arrow far left as I can. Push enter. And then the second curve, of course, 4, enter. And try and get close. And there is your intersection. You know for sure, if you're doing a problem like this, quiz, test, whatever, you know that y has to be 4, right? If it's a horizontal line, y has to be 4. So it looks like we are at 0.05. 4. That's supposed to be a 4. Sorry, the handwriting's not great. Let's do it again. Second trace 5. There we go. And I'm just right arrowing and left arrowing to get me close to the intersection point. First curve, I'm just going to push enter for the second curve. The guess, you want to get as close to that intersection point as you can. And in this case, it is 1.48. I'm going to move this. Okay, so that is the answer for the second problem. Okay, at this point, you're going to want to pause. We're going to look at page 339, number 4. Page 339, number 4. So you can see that's a chemistry problem. A chemist has a 100-gram sample of a radioactive material. He records the amount of radioactive material every week for 7 weeks and obtains the following data. So it says, using a graphing utility, draw a scatter diagram. So push pause and go ahead and enter. Well, maybe you don't remember how to do it. To enter the data, this is on the last test, stat, edit. I have a ton of stuff in my calculator from doing previous problems, so I'm actually glad this came up. I don't want all this data. I definitely don't want all this data. Don't push delete. If you push delete at the top right here, my list 3 has data in it, and list 3, the actual L3 is highlighted. If you push delete, which I'm not going to do, the whole list is just going to disappear. You want to push clear. I don't know if you can see my finger right here. I want to push clear, and now list 3 is cleared, not deleted. So I'm going to go ahead and clear out some of my data. I don't need this anymore. I was doing something differently. It doesn't pertain to our class. Another way you can clear out your data, this is great as well, is second plus sign, which accesses the memory catalog. And you'll see that if you go down to number 4, push enter, it will clear all your lists. So that's if you would like to do it that way instead. So again, that is second plus. So you do second plus, and then this catalog comes up. So that's just another way to do it. Doesn't hurt to know several ways. So stat, I'm going to enter my data. 0, 1, 2, 3, 4, 5, 6. 188.3. Okay, just going to do a quick check to make sure that my list 1 matches my list 2. Should have that data put in. I'm going to quit. And the problem says to draw a scatter diagram. Okay, so if you've forgotten how to do that, you're going to do first of all, you have to make sure your plot is turned on. Make sure your plot is turned on. Nothing will show up if your plot's not turned on. And I'm going to arrow down and I'm going to turn off the equations that we just did in the previous problems. There's no need to delete everything when you can have all these, 10 choices. I'm going to do a zoom 9. Whenever you're doing a stat plot, you want to do a zoom 9. Whoa. Okay. It looks a little linear. It looks linear. The directions say use a graphing utility. Why don't they just say graphing calculator? Build an exponential model from the data. Okay. This is no different than building a quadratic model, a linear model, exponential, logarithmic. We'll talk about logistical in a little bit. Stat, calculate, and here's all your options. Linear, quadratic, cubic, quartic, linear when you switch a and bx, natural log, exponential, etc. So I'm going to calculate an exponential regression by hitting 0. Now, I'm glad this happened. Mine has in here list 3 and list 4. The problem I was doing previous to this, you saw how I cleared out that data. So I need to change my list 3 and my list 4. So I'm actually really glad some of this is happening because it might happen to you as well. Above the number 1, oh, you can't see it because of the glare, but if you look on your calculator, above number 1, it says L1. Above number 2, it says L2. So I need to change this second, number 1, and you can see that now my list says list 1. I want my Y to be not list 4, but list 2. So I'm going to do second, 2, and now I have list 2. I want to store the equation. I have 4 equations in there. Okay, so I'm going to store it in equation 5, but now I need to start over. Where are we? Stat, calculate, exponential, list 1, list 2, and I'm going to store it alpha, trace. Again, that was alpha, trace. And I'm going to put it in number 5. Push enter, and here you go. Whoa. I have this R squared and this R number. Oof. We'll come back to that in just a minute. Wait. What's all this A? What's this B? They give it to you. Y equals A times B to the X. That's exponential. A times B to the X. And they tell me A and they tell me B. So let's write that down. Y equals A. I will tell you to do the nearest hundredth. I always have every time we've done a problem. Parentheses are important. B, which is 0.88 to the X. For writing it on my paper, I'm rounding to the nearest hundredth. Just follow the directions. I think I've always told you. But for my calculator, I'm going to leave it all in there. So I'm going to tell you about the whole R squared thing in just a minute. So is my plot turned on? It is. There's my exponential equation. Let's do a graph. Let's do a zoom 9 for a zoom stat. Look at that. It's pretty good. From here, I can make all the assumptions, or sorry, not all the assumptions. Okay, so we graphed the exponential, and then we want to determine half-life of the radioactive material. Okay, so I'm actually on part E. This was part B. Part A was plug it into the calculator. We're going to come back to part C. For right now, we are going to skip this. We're going to come back to it in a minute. Part D, graph it, which we did. And then part E says, determine the half-life of the radioactive material. So if I want to find the half-life, if you look at the table, when at week 0, there were 100 grams. So if I want to find the half-life, At week 0, we had 100 grams. So at what week, half-life, 50 grams? When will there be 50 grams? That's what half-life is, when you have half of the substance that remains. Okay, so I want to know, when is Y going to be 50? Guess what? You just did this in the previous 2 problems. Let's graph it. That's when Y is 50. When do they intersect? Second trace, intersection. Where did I get the 0 and the 50? That was given to me in the table. And about 5.3. 5.2999. That's 5.3 weeks. Okay, what else did they ask us to find? How much radioactive material will be left after 50 weeks? Here's your table. My table's in a different place probably than yours. Second graph gives you the table. I'll do second window. Start at 50. And 0.14062. Again, I did, well, there's a couple ways you can do this. I changed my table. So I did second window and I started at 50. The other way you can do this, be careful. I'm going to plug in independent variable as X, and I'm going to change my dependent to ask. If you go back to your graph, I think I just messed that up. Oh, here we go, table. Notice now how my table is empty. The bottom X is 55. If you wanted to know what happened at week 100, you should be able to type in 50. Okay, so clearly I am messing that up somewhere. I thought I could type in 50. Clearly I am making a mistake. I'm going to go back to my table set and turn this back to auto. Sorry about that. I clearly made a mistake there somewhere. So again, what you should do, for sure that works. Window, change it to what you want, and then go back to your table. And there it is. Okay, and then, oh, so the answer was 0.14 at 50, it was 0.14. And then when will there be 20 grams of radioactive material? So they're asking you when. That means I'm looking for X. So I'm going to type in 20. That's going to work slowly. And you look, 20 doesn't even show up on my screen. 20 doesn't even show up on my screen. So, let's take a look at this. If you look at your window, the Y minimum is 36. If I want to know when Y is going to be 20, so let's make our minimum 0. Okay, so here it goes, it's working. Well, what do you think about that? It appears that it's never going to be 20. It appears that it's never going to be 20. So let's solve it the old-fashioned way. It was 20, wasn't it? Yeah. Divide both sides by 100.33. So 100, let's see, 20 divided by 100.33. 0.1. So for the sake of writing it, it's approximately 0.20, which I should have known. Sorry, that was kind of lame. So on the calculator, it doesn't appear that they ever intersect. It doesn't appear that they ever intersect. So let's just see what happens. So I'm going to do logs. My base is 0.88. So this is the log base 0.88 of 0.2 equals x. So the calculator is not always going to, be our best bet. You can plug this into your calculator, or you can use change of base, or well, you can use change of base and then plug it into the calculator. But I like alpha window number 5, 0.88 to 0.20, and the answer is 12.59. So you can either do alpha window number 5, which is super helpful. I think many of you know this by now. Or you can plug into your calculator the log of 0.2 over the log of 0.88. So the answer to this was approximately 12.6. weeks. Okay, we are going to come back to part C. So for the homework, when they're asking you to express using, it says this, it says express the A of t as a sub 0 equals a sub 0 times e to the kt. So unfortunately, you haven't done this yet. I know it's kind of backwards. I thought that a video on the calculator would be not so bad to do today versus trying to teach you all this in a 45-minute video. So you can skip part C. One thing I really, really want you to do though, my calculator's turned off. You know how my calculator had that whole r squared thing on it? Okay, I just made this up, okay? My calculator has an r squared, and it is doubtful that yours does. Supremely important. Mode. If you arrow down to where it says stat diagnostics, arrow down to stat diagnostics, and you are going to want to turn those on. This helps you determine which regression is best. So on the exam, you were supposed to look at the data and it clearly modeled a quadratic regression versus a linear. But now that we are going to be doing exponential regressions, logarithmic regressions, logistical regressions, which we'll talk about next week, it's going to be very difficult to tell which one is best. And so your calculator, do another problem and it will say r squared. And what you want is you want r squared to be as close to 1 as possible. This means that the data and the regression have a 1-to-1 relationship. So the closer it is to 1, think about it as 1 is the same as 100%. As a percent, 1 is 100%. So that means they are 100% matched. So this is going to help you in the future as we decide which regression is it. Okay, so the homework, a lot of it is just plugging and chugging into the calculator. Actually, I think all of it is plugging into the calculator except for the couple of review questions on page 342. There's a couple of review questions.